You are welcome to my YouTube channel. My name is Kakusa Blessings. Before we move on, I would love you to subscribe to this channel and give a like to this video you are watching. In physics, we are going to revise on transformer. Okay, so at the end of this lesson, you should be able to define a transformer, differentiate the two types of transformers, explain the operation of a transformer, calculate the voltage, number of turns, efficiency, power, and the current of a transformer. We are going to begin with this question, which is saying, what is a transformer? What is a transformer? Okay, so a transformer is simply an electrical device that varies voltage of an AC supply. Okay, so this same transformer is made up of a primary coil, which is located to the left hand side, and a secondary coil located to the right hand side. It is also made up of a soft iron core. Okay, so we've got the two types of transformers, namely the step up transformer and the step down transformer. So the step up transformer has the voltage to the secondary coil, which is the output voltage, is higher than the voltage to the primary coil, which is the input voltage. So this step up transformer steps up the voltage from 100 volts to 240 volts, as you can see on the small diagram we have here. Okay, so this step up transformer has more number of turns to the secondary coil than to the primary coil. Okay, we move on to the step down transformer. So the step down transformer is just the opposite of a step up transformer. So this step down transformer has more number of volts to the primary coil as compared to the secondary coil. As you can see on the diagram, to the left hand side, which is the primary coil, it is written as 240 volts, and to the right hand side, which is the output voltage, it is written as 100 volts. Hence, this step down transformer steps down voltage from 240 volts to 100 volts. So this step down transformer has fewer number of turns to the secondary coil than to the primary coil, meaning the number of turns to the primary coil are very big as compared to the number of turns to the secondary coil, which is the output voltage. Okay, we move on to the ideal transformer. What is an ideal transformer? A transformer with an efficiency of 100% is called an ideal transformer. So if a transformer has got is 100%, is working at 100%, it means it has no losses in power. Hence, it is qualified to be called an ideal transformer. So how a transformer operates? How does a transformer operate? So a transformer just varies voltage of an AC supply. The primary coil is connected to the AC supply, while the secondary coil to electrical appliances. So the primary coil cannot be connected to the direct current. So here the AC stands for alternating current, so meaning that current varies, is able to vary. Now, this primary coil cannot be connected to direct current, which is the DC current. No. Why? Because direct current is unable to induce voltage to the secondary coil. By induction, I'm implying to say the output voltage to the secondary coil cannot be generated. Okay, so this transformer also operates using the principle of electromagnetic induction. Yes, so it works with the principle of electromagnetic induction. So there are simple formula used on transformer calculations. So the formula used on transformer calculations are as in, when you want to calculate the voltage either to the primary coil or to the secondary coil, we use this formula here on the first here. Okay, so the voltage to the secondary coil is directly proportional to the number of turns to the secondary coil, and the voltage to the primary coil is directly proportional to the number of turns to the primary coil. So the Vs there is standing for voltage of secondary coil, the Vp is standing for voltage of primary coil, Vp, Ns, number of turns to the secondary coil, and Np, the number of turns to the primary coil. So you may also want to calculate the current. So the current is calculated as the voltage to the secondary coil divided by voltage to the primary coil, and you equate these voltages by current to the primary coil, which is IP man, divided by current to the secondary coil. Okay, so how to calculate efficiency? So efficiency is calculated as power output divided by power input multiplied by 100%. This is how calculations are done on transformer. Okay, so a question may be asked to say, why is a soft iron core used rather than steel? So a soft iron core is used because it is easily magnetized and demagnetized, while steel is not easily magnetized nor demagnetized. Another question may be asked to say, between the two types of transformers, which one is found at the power plant where power is generated, and which one is found in communities where electricity is tapped from and into our houses? So a step-down transformer is found at the power plant where power is generated because it steps down the voltage from 240 volts, like the way it was in our example, from 240 volts to 100 volts. This is because the voltage at the power plant is very high for our electrical appliances to withstand that type of voltage. And a step-up transformer is used in communities. This is because it varies voltage at a normal rate. Hence, it can qualify to be used for our electrical appliances. Thank you for watching this video. Remember to subscribe and give a like to this video.